Just like we did in our last video, I'm going to begin graphing this logarithmic function by first describing the transformation, specifically the shifts, and then stating the domain range and the equation of the asymptote before switching over to my graphing calculator to get a more accurate looking sketch. So I begin by describing my transformations. The h and the k values, what we talked about in the last video, describe how my graph has been shifted. The number in the parentheses, if there is a number in parentheses, will tell you your horizontal shift, and it does the opposite of what it says. So that +1 actually moves my graph to the left 1, which is going to be the important number I need for finding my asymptote. The k value then, the number being added or subtracted not in the parentheses, will be your vertical shift. It does what it says it will do. It moves the graph down 4, but it doesn't affect where the asymptote is. Okay. My range for a logarithmic function is always -infinity to +infinity. It goes forever down and forever up. My asymptote, though, is a vertical line, normally at x equals 0, but any kind of horizontal motion will shift where that asymptote is located. Because we've already said I've moved the graph to the left 1, my asymptote is going to be x equals -1. So I'll go ahead and draw that dashed line in there, kind of like a wall stopping where my graph is going to be able to go. I can't cross or touch that asymptote. And then finally, that helps me describe my domain. My domain is going to be from -1 all the way to the right forever, so from -1 to infinity, with a parentheses because I can never touch -1. At this point, I'm going to switch over to my calculator because the only other thing I know by hand, since my base value is a number less than 1, I'll have a graph that looks something like this. It'll start close to that asymptote and then curve away from it. But because I want to be a little more accurate, I'm going to plot this or graph this on my calculator in order to find some points to plot this more accurately. And I'll show you a few ways that you could work on getting this typed into your graphing calculator. If you watched our last video, I want to start by showing you the two different ways you can get this equation typed into your calculator. The top equation is by far the easiest one to do. I've just literally typed it in exactly as I see here. You can do this if your calculator has the log base feature. To tell if you have that, hit alpha and then window, and you should see option 5, this thing called log base. If you have, oops, I selected the wrong one. But if you have that option, you can go ahead and just type in exactly as you see right here. I mean, it's the easiest way to do it. If you don't have that, I've typed in Y2. What else you can type in? It's something using the change of base formula, which we'll talk about more in another video. To do this, we're going to just use the log button right here if you don't have the log base feature. So I've typed in 3 and then log of x plus 1, exactly what you see in parentheses here, close off the parentheses, divide it by log of whatever the base is, so log of 1/2. And notice again, I've closed off the parentheses and then that -4 is at the end. So it's a little more involved to get that typed in, but you can certainly do this. To plot points, then I'll take a look at what my table shows me. Notice in both columns I get the exact same points, just showing me that those two equations were the same thing. There's errors up here because any number smaller than -1, we said we couldn't use. You can't do the log of a negative number. So all of those get me errors. As soon as I get past -1, I start to get actual points. So I found these points were easy to plot, 0, 4, and 1, -7. I've got those points plotted. And then this point as well, 7, -13. A lot of these are irrational because that's what logarithms tend to give you, but you should be able to find a few good points in there. So I've got those points plotted. Because my base was a number smaller than 1, I get the logarithmic curve that starts close to the asymptote and then curves away from it down here. If you look at the graph, again, I'm going to point out the same thing I pointed in the last video if you watched it, I've got to be really careful because it looks like my graph just ends. It looks like it begins right there and then continues forever in that direction. I know that my graph actually goes up to infinity. My range is -infinity to +infinity. So the graph stops on my calculator screen because of the resolution, but I need to be smart enough that when I graph this, I know that graph goes up forever. It's just getting so steep over here, but make sure you include that arrow because the graph does go up forever. It does not end right there the way the calculator is making it appear.